Alright, let's go through some of these problems together. First one's pretty simple. You're given this triangle with these two sides, and we're asked to find the values of all 6 trigonometric ratios. So to start with, we need to figure out what this missing side is. So to do that, I am going to go and use the Pythagorean theorem. So 8 squared plus 10 squared equals the hypotenuse squared. So that means the hypotenuse, that means the hypotenuse squared is equal to 164, which means the hypotenuse equals square root of 164, which is about 12.8. I don't know if they wanted to leave it in square root form or what. We'll just go with 12.8. Alright, so now I'm ready to do all of these values. Sine of A is the opposite over the hypotenuse. So it is 10 divided by 12.8. The cosine is the adjacent divided by the hypotenuse, so that's 8 divided by 12.8. The tangent is the opposite side divided by the adjacent, so that is 10 divided by 8, which equals 5/4. The secant, now we can just go back and look at these. Secant and cosine are inverses of each other, so the secant would be 12.8 divided by 8. Cosecant and sine are inverses of each other, so 12.8 divided by 10, and cotangent and tangent are inverses of each other, so 4 divided by 5. Alright, now we're asked only to find just one of the missing sides. So that's this guy right. Oh, for all of the missing sides, sorry. Okay, so let's do angle B first. That's easy peasy. If that's 30, then this must be 60. Then if I'm going to find this side right here, that's the adjacent side relative to this 30-degree angle. I know the opposite side, so I can say the tangent of 30 degrees equals the opposite side, which is 7, divided by the adjacent side, which is b. So this is a fun little one to mess around with, because in this case I'm not going to multiply both sides by 7 because the 7 is on top. So what I would do here is actually multiply both sides by b, and then divide both sides by the tangent of 30 degrees. And so what that does is it ends up having the effect of just switching the tangent 30 and the b. That's a fun little trick that you can always do with fractions. So if tangent of 30 degrees equals 7 over b, that means b equals 7 divided by the tangent of 30. And according to mi calculadora, 7 divided by the tangent of 30. Again, we need to make sure we're in degrees, not radians. That works out to be 12.12. Okay, so that was side B. Then to get side C, we could use the Pythagorean theorem if we wanted to. I'm going to just go ahead and stay with the trig ratios here. If I know this is 30 degrees, I know this opposite side is 7, and I'm trying to find the hypotenuse. Opposite and hypotenuse is sine. So sine of 30 degrees is equal to the opposite side divided by the hypotenuse, which means, as I described up here, that C is equal to 7 divided by the sine of 30. And that equals oh, 14. Even, oh yeah, sure, because it's a 30, 60, 90. Alright, so look at number 5. Again, angle A is easy because you know these two things are going to add up to 90 degrees. So angle A is 28 degrees. Then if I want to find side A, and I know that this is 62, 10 is the opposite side, A is the adjacent side, so that means I'm going to use the tangent of 62 degrees is equal to 10 divided by A, which means that A equals 10 divided by tangent of 62, which is, I'm going to need a little more room there, looks like. 10 divided by tangent of 62 is, wait for it, assignment builds, 5.3. Okay, let's get that to where we can actually see it. Okay. So that's side A. Again, we could use the Pythagorean theorem at this point to find side C, but I'm going to just stick with the trig stuff. Now I know that this is 62 degrees. I still have the opposite side, and I'm trying to find the hypotenuse. That would be sine. So I could say the sine of 62 degrees is equal to, for the opposite side, 10 divided by the hypotenuse C. So do the old switcheroo with that fraction and rewrite it as C equals 10 divided by the sine of 62 degrees. And then ask my calculator what that works out to be. What are we doing? Sine? Okay, and that's 11.3-ish. Which makes sense because that's the hypotenuse that we would want and expect for that to be the longest of the three sides, and it is. Alright, one more of these silly ones. We know that if this is 65 degrees, B is equal to 25 degrees. Then I'm going to find my missing sides. So again, I'm going to use the 65 degree angle here to start. Let's find side A. That's the opposite. This is the hypotenuse. That's sine. So sine of 65 degrees is equal to the opposite side divided by the hypotenuse. So now notice that my variable is back on top again. See here the variable was on the bottom, here the variable was on the bottom, so that's why we had to do that little trick. Now I don't have to do that trick, I can just say that A is equal to 10 times sine of 65 degrees, because I've just multiplied both sides, multiplied both sides by 10. I'm just kind of left my little symbol. So I just ask my calculator, what is 10 times the sine of 65 degrees? And it tells me 9.06. Okay, so now I still have to find side B. So if I use 65 degrees again, hypotenuse is 10. This time the side that I'm looking for is the adjacent, so that's going to be cosine. So the cosine of 65 degrees equals the adjacent side B divided by the hypotenuse. So multiply both sides by 10, and B equals 10 cosine 65 degrees, which is, so just changing this to cosine, huh? 4.23. Okay, 2, 3 there, fella. And we can do a little check on this also. The hypotenuse is the longest side as expected. The side A is bigger than side B because it's across from a larger angle. So as far as we know, no reason to think that those answers are wrong. Okay, let's take a look at some word problems. I know you love these. So in this case, start with an easy one. 33-foot ladder leans against the building so that the angle between the ground and the ladder is 80 degrees. How high up does the ladder reach? So we are looking for the opposite side. We have the hypotenuse. That is the sine. So the sine of 80 degrees is equal to the opposite divided by the hypotenuse, which means if we multiply both sides by 33, 33 is equal to the sine, or y equals 33 times the sine of 80, which is 32.5. Okay, so kind of weird. The ladder's 33 feet. It's 32.5 feet up the side of the wall, so it's almost about the size of the ladder. That seems like that might be a dangerous angle for you to be on a ladder. Okay, another one. The angle of elevation to the top of a building in New York is found to be 9 degrees. So this is the angle of elevation. In the example problem, they refer to this as the angle of inclination. Those are the same thing. So this is 9 degrees, so not drawn to scale, from the ground at a distance 1 mile from the building. Using this information, find the height of the building. So we are looking for the opposite side. We have the adjacent side. That tells me that we're going to use our old friend tangent. So the tangent of 9 degrees is equal to the opposite side divided by the adjacent side, which means that y is just equal to the tangent of 9 degrees. Because we're multiplying by 1, so that doesn't change it. So, let's figure out what the tangent of 9 degrees is. That works out to be 0.158. Okay, so that means that the height of the building is 0.158 miles, so we should probably take this and change it into feet. That would make a little bit more sense. So I'm going to go times 5,280, and that tells me the building is about 836 feet tall. So, it's a pretty tall building, 83 stories-ish, 80 stories maybe, usually about 10 feet per story. Alright, moving on here. Okay, now things get fun, but we are going to, we're not going to learn from our mistakes because we don't know, in this case, the height of the window. Let me get a little ahead of myself here. It says the radio tower is located 400 feet from the building. Nice radio tower, huh? You're welcome. From a window in the building, nice window, huh? A person determines that the angle of elevation to the top of the tower is 36 degrees, and that the angle of depression to the bottom of the tower is 23 degrees. How tall is the tower? So this time all we know is that this is 400 feet, but we can very quickly say that if that's 400 feet, this is 400 feet, and that's going to make this problem a lot easier. So now I'm going to break this up into 2 triangles, the one on top and the one on the bottom, and use those triangles to figure out the total height. Okay, so let's do the top one first. I'm looking for the opposite side. I have the adjacent, so that's tangent. So I know that tangent of 36 degrees is equal to the opposite divided by the adjacent, which is 400. So that means that that piece of the tower that height is going to be 400 times the tangent of 36 degrees. And 400 times the tangent of 36 degrees is about 290.6 feet. Okay, then to find the other piece down here, I'm going to go tangent of 23 degrees is equal to this side y divided by 400. Once again, opposite divided by adjacent. So this is basically the same thing, just with a different angle. I'm going to go 400 tangent of 23 degrees. And if I do that, I'm just changing the angle to 23. Then that would be 169.79 feet. 169.8 feet. So if I add those together to find the total height, the height of the tower is equal to x plus y, which is that plus 290.6, about 460 feet. Okay. So yay on that. All right, moving right along. So this is a little bit different because they have not given us this distance, and so this is going to cause us a considerable problem, and I already regret assigning this problem, but we'll just work through it. What else have we got to do today? So the 200-foot tall monument, I don't know what that is located in the distance. From a window in a building, a person determines that the angle of elevation to the top is 15 degrees, and that the angle of depression to the bottom is 2 degrees. How far is the person from the monument? So our problem here is that we are not given any of the sides of the smaller triangles. This side here, 200 feet, is the side of this triangle right here, but that's not a right triangle, so we can't use our trig stuff to figure that out. So this is going to get a little bit complicated, so fasten your seatbelts. What I'm going to do is I'm going to call this part right here that distance of the top triangle y, which means that this guy down here is 200 minus y, okay? Alright, so now I'm going to set up two different ratios, both using tangent. And I'm going to start by saying that the tangent of 15 degrees is equal to y divided by x, opposite over adjacent. And then I'm going to say also we know that the tangent of 2 degrees is equal to the opposite side, 200 minus y divided by x, okay? Okay, so now we have two equations with two variables, so we can solve those using a little bit of algebra. So what I'm going to do is I'm going to solve them both for x, and then set them equal to each other. So to do that, I need to do my little switcheroo trick because I'm dividing by x. So that means that in this case, x would equal y divided by the tangent of 15 degrees. And then in this case right here, I can rewrite this as x equals 200 minus y divided by the tangent of 2 degrees. Okay, so like I said, now since I have these both solved for x, I can set them equal to each other. So y divided by the tangent of 15 degrees equals 200 minus y divided by the tangent of 2 degrees. Okay? And so the algebra here isn't really that bad. It's just kind of a mess because these things right here aren't whole numbers. But what I'm going to do is I'm going to cross... I guess I better... yeah, I'm going to have to cross multiply. So this y is on top, this tangent of 2 is on the bottom. If I cross multiply those, I get y times the tangent of 2 degrees on one side. And then when I cross multiply on the other side, I get the tangent of 15 degrees times 200 minus y. Okay, so now let's go ahead and figure out what those tangent values are. So the tangent of 2 degrees is going to be a really small number. That is 0.0349, and then that, so 0.0349y equals the tangent of 15 degrees, which is 0.268 times 200 minus y. Okay, and now if we just keep our heads down and do geometry the way, or do algebra in the way that our grandmothers taught us, we'll be just fine. I'm going to leave this 0.0349y on the left side alone, and I'm going to distribute the 0.268. So I'm going to take that and go first times 200. So that gives me 53.58. No, it's really 53.59. Minus, so that was the 0.268 times the 200. Now if I go 0.268 times minus y, I get minus 0.268y. So we're almost done here. So that means that to figure out what y is, I have to add 0.268y to both sides. So 0.0349 plus 0.268 equals 0.3029, and that still equals 53.59. So then we're almost there. Figure out what y is. I can divide both sides by that. So 53.59 divided by 0.3029 equals about 177. Okay. Alright, but that's not what we want to know. We want to know what this distance is, but that's easy now that we know that. We can just take that and plug it into one of these two things here. I'm going to choose to plug it into this one right there. So we know that x is equal to y divided by the tangent of 15 degrees. So that means 177 divided by the tangent of 15 degrees equals okay, so we're about 660 feet away from the mysterious monument, whatever that is. Alright, so that was kind of a mess. That was a tough one. Especially hard to do that by video where you guys can't ask me questions as I go along. So good for you if you hung in there and got that figured out.